Hey guys, welcome to today's video. In this video we are going to solve one more Leetcode question, and the question number is 1022, the sum of root to leaf binary numbers. So let's understand this question. So you are given a root of the binary tree where each node has a value 0 or 1. Since it's a binary tree but it has a binary value also, so which is either 0 or 1. So each root to leaf path represents a binary number starting from with the most significant bit. So from top to bottom, so you calculate the number like this. If our root is 1 and the leaf are 100, so the binary number becomes 100, which is 4. Okay, now for example, if the path is 01101, then this could represent 01101 in binary, which is 13. For all the leaves in the tree, consider the number represented by the path from root to that leaf, which is like just I told, from root to leaf, whatever will be the number that will be represented by that path. So return the sum of these numbers. So we need to return the sum of these numbers. It means like this is one number, 100 becomes one number, 101 becomes another number. So 101, I think, which is 5. Yeah, so 101 becomes 5, 110 becomes 6, so which is 110 becomes 6, and 111 which is becomes 7. So we need to give the sum of all the paths, so which is 4 plus 5 plus 6 plus 7, which is 22. Okay, so you can pause and you can try it with yourself. The main thing to understand over here, how do we calculate this number? So first of all, even though like it is easy to calculate the path, right, 100 101, so it is the from root to leaf we are calculating the path, which is fine. So we have these numbers. Now how do we convert it to the decimal number? So this is the main thing. Okay, so which will impact our the time and the space complexity. So there is a concept which we need to understand to solve this question, so which will make this question much easier. Okay, so let's understand this concept. So whenever we do a left shift of the binary digits, so it gets multiplied by 2. So what I'm saying, suppose we have this in binary, so which represents 1, right? So when we do the left shift by 1, so when we do the left shift of this, so we add a number over here. Okay, so when we do a left shift by 1, so it becomes 2, so which is a double, so you're multiplying by 2, right? Similarly, if this binary we do a left shift by 1, then it becomes 100, which is 4. So if you see, it is getting double, right? So there is a formula. So if our sum is there, if you multiply the existing sum by 2, and if you add the digits, the significant digits over here, okay, to current bit, so it will give you that number. So I'll give an example. So you use this for calculating this example. Suppose this is our binary, which is in decimal system is 5. So suppose we use this method to calculate. So suppose sum is initially equal to 0, right? Now what I'll do, my initial sum is 0. Now I'll use this bit. Now sum multiplied by 2. So our existing sum multiplied by 2 plus our current bit, which is 1. Okay, we'll do that. Okay, now our again the sum is become 0 plus 1, which is 1, right? Now this is done. Now we will do sum. Okay, the new sum will become existing sum multiplied by 2 plus our bit, which is 0. So 1 multiplied by 2, so it becomes 2, right? Now the existing sum is 2 multiplied by 2, and now we'll add our this bit 1. So 2 multiplied by 2, 4 plus 1 equal to 5. So you get the decimal number by 5. Okay, now you will say why it works. What is the reason behind it mathematically, how it makes sense to add the sum multiplied by 2 and plus the bit, it works like that. So I'll tell you. So suppose 100, this is our value. How do we calculate it? Okay, so we calculate, suppose this is b0, b1 and b2, or like dot 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 bn. Usually our digits are like that, right? How do we calculate? b0 into 2 to the power n plus b1 into 2 to the power n minus 1 dot 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 b0 into 2 to the power 0. So that's how we calculate our value, okay, of the binary digit, correct? This is how we calculate. So if you see this formula, suppose val of I is equal to what we did, this, right? So it is previous sum multiplied by 2. So its value of I is value of I minus, value of I minus 1 plus b of I, right? So this is the formula, right, what we used for our calculation, right? Suppose if our value is suppose 101, so it is 0, it become b1 and it's become b2. So okay, so according to this formula, so our b2 is 2 into b1, okay, because it is I minus 1 plus b2, okay. And what our b1 will become? So our b1 will be 2 into b of 0 plus b of 1, okay. If we substitute this over here, so our b2 will become 2 into b0 plus b1, okay, and plus b2. So similarly, if we substitute b0 also, and if we calculate, so this will come as our existing formula, this, okay. So if we calculate it and we substitute everything, so it will come mathematically to this. So that's how this works. So if you need to remember, so whenever the concept is, whenever we multiply our existing sum by 2 and plus we add our existing digit to existing bit to it, it will give us the decimal value of that system, okay. Now we can go back to our code. So that was the main concept to learn from here, like how do we calculate the binary, how do we convert our binary digits to decimal system while going through our tree, okay. So the code of this will remain very simple. So if our root is null, then our sum will be 0, okay. Now we create one more method, a helper method called sum, where we'll pass our root and the initial sum as 0, which will give me the final value, okay. We'll create a private method which will return me the int. The method name is sum and the value is tree node root and sum, okay. Now what we are going to write, so if our root is null, then we can return the sum as 0, okay. Now our sum will be twice of the existing sum plus our current bit, because all root dot val, all the node value is 1 bit, right? And now we need to give when we come to the leaf, our sum will be written when we come to the leaf, right? So if our root dot left is null, and our root dot right is also null, then we return our sum, okay. And now we need to give back all the sum of the path. So what we are going to return as sum of root dot left sum plus sum of our root dot right comma sum, okay. So code was very simple, the main logic was this, okay. So let's try to submit this. So it worked. Let's try with all the test cases. yeah, so it beats 100%, and yeah, it got passed. So let me know if you understood this, and see you in the next. Thank you.